Okay, so far in the school year, we have learned a few equations, a few formula. The first one being the slope equation, the slope formula. We have m equals y1 minus y2 over x1 minus x2. Some people prefer having the first point and the second point switch up a little bit and have y2 minus y1 over x2 minus x1. So this is the slope formula. And then in lesson 7.1, when we start to look at straight line, we have y equals mx plus b. We have m being the slope, and we have b the y-intercept. And then in the previous lesson, 7.2, we did this linear equation, ax plus by plus c equals 0. This is the general form. And you need to do a small calculation to obtain the slope, to obtain the x-intercept, and the y-intercept as well. So we have negative c over b for the x-intercept, and we have negative c over a for the y-intercept. So moving on to lesson 7.3, we are going to learn yet another formula to come up with the equation of a straight line, and we call it the slope point form of a linear equation. Now, based on the name itself, you can probably tell that in order to come up with this form, you need the slope of a line and you need a point that is on the line. So how do we use these two information to create an equation for your straight line? It all goes back to the slope formula. So when you want to if you were to take a look at the slope formula again, here is the slope formula. If we have the slope of a line given to us, and if we already know one of the points on the line, I basically will have this, and that in the equation. But what happened is we don't have a second point on this line. Well, in fact, the second point on this line could be any point on the line. So for that reason, if we are now using any random point on this line, I can simply call the x2 and y2 as some random x and y coordinate, which means if I'm to start with the slope formula, replacing the x2 and y2 with x and y, we will then come up with the equation that we call slope point form. Now, of course, not many of us like to work with denominator. So if you choose to not work with denominator, you can multiply this denominator to the other side, and therefore giving us m times the bracket from the denominator on the right side. Or on your provincial exam, they will have this equation written in this way. So when you are given, anytime when you are given the slope of a line and one point on the line, so you have the xy coordinate for that particular line, you can then come up with the equation for the line that you want to work with. So here in example number 1, if I have a line with a slope equals 2, and this line is to pass through 3 and negative 4, I will then be able to come up with the slope point form using y minus y1 equals m times x minus x1. The point here, they are to give, we can use these two numbers for x1, y1, and here we have slope equals 2. So the number goes here. 3 is for x1, negative 4 here is for y1, and I have slope equals 2. And we will simply make a substitution to the equation. Y minus negative 4. So you end up getting y plus 4. And with slope equals 2, x minus x1. From the above, we have x1 equals 3. So this will be the equation in slope point form. But let's say if you don't like to work with equation that has bracket in it, like many people tend to open up the bracket, expand it a little bit, and if you choose to expand it out, 2x minus 6, and put everything together, you will then be able to come up with the general form. So moving the y to the other side, the y becomes minus y, and the plus 4, bring it to the other side, becomes minus 4. Minus 6 minus 4 will give us minus 10, and this will then be the equation in general form. This is the general form for part B. So once again, you can now obtain the equation for the general form by just expanding the bracket and then put all three terms to the same side. I can also use this equation and convert it into slope-intercept form. Slope-intercept form means y equals mx plus b. So I want to isolate the y by bringing it back to the left-hand side. My equation will now be in slope-intercept form. And as you can see, we are still having slope equals 2, but now we also have the y-intercept indicated in the equation.